Alright, so here we go. We're going to take a look at properties of logarithms today. So, get your piece of paper out. And we'll start talking. On Friday, we already talked about some properties of logarithms, some basic properties of logarithms. But we're now going to get into a little bit more extended versions of some more properties that kind of extend beyond just those basic ones. All right. One thing I want to note here about these properties we're going to be talking about. Okay, these properties are true for natural logs, right? Base E, and it's true for common logs, which is the base 10, log base 10, and all the other logs too. Okay, for some reason, whenever students see like a natural log, like ln, okay, of something, they think it's different than any other than other logs because it looks different, right? It's ln instead of log, but still it's the same kind of thing. It's still a logarithm, okay? So you treat it as such. So the properties still apply here. So don't freak out on like a homework or something like that if you see a homework question, if you see, you know, a natural log or just plain old log, right? The properties still apply here. So property number one that we're going to get into, all right, talk about, is that log base A of u times v, and I'll just indicate u times v like that by writing them next to each other, is equal to log base A of u plus log base A of v. And so what you see here is we have a product inside the natural logarithm. It becomes addition on the outside, breaking up that product into the sum of u and v there, log base A of u, log base A of v. Okay. So that's one thing. So for just as a quick example here, if you see, for example, log base 4 of 16x, okay, we could say that's log base 4 of 16 plus log base 4 of x. All right, you see we had a product here between the 16 and the x, and then we were able to break up that product into a sum, log base 4 of 16 plus log base 4 of x. All right. The purpose of this is that we aren't really able to simplify log base 4 of 16x easily, but when we break it up into these two pieces, we can evaluate log base 4 of 16. Remember, when you evaluate a logarithm, it's asking the question 4 to what power gives me 16, or gives us 16. So the answer there would be 2, right? 4 to the second gives us 16. So this value is 2 plus log base 4 of x. And so now we kind of have a simplified version of that we otherwise would not have been able to simplify without that power. Or without the power, without the property. All right, next, another property we have here, log base A of u over v. Okay, log base A of u over v, or divided by v. Well, you can probably figure out what this one's going to be, right? If log base A of u times v was log base A of u plus log base A of v, then log base A of u divided by v is going to be log base A of u minus log base A of v, like that. Okay, so division changes to subtraction between the two pieces, and multiplication changes to addition between the two pieces. All right, so let's again see another example of that, just so you can kind of see that at play here. Let's take, for example, the natural log of x over 2. Okay, remembering again that natural log is a logarithm, so all of the properties still apply here. It would just be log base e is one way you could write it. Well, we have division, so we can change that to natural log of x minus the natural log of 2. Okay. Here there's no easy way to simplify this. Natural log of x doesn't really simplify. Natural log of 2 would also not simplify because e to some power is not going to, we can't come up with some easy power of e that makes 2. So that doesn't simplify any further. We'll just have to kind of stop there. right. One more major property here that we're going to focus on today, and that is that the log base a of some number u, or something u to the nth power. All right. That is equal to n times log base a of u. So you'll see here what kind of happened was the exponent here for the u, that n exponent moves to the outside, n times log base a of u, to give us that, this kind of simplification, or able to, ability to rewrite a little bit. Now again, how is that helpful? Well, for example here, if I rewrite this as if I do a problem, let's do like log base 3 of 9 to the 5th. Okay, so log base 3 of 9 to the 5th, that's equal to 5 times log base 3 of 9, which again, we could evaluate that from here, or we could continue and say, oh, but 9 is really 3 squared. Which that means this 2 I can also pull out front. That's already with the 5, so it'll become 10. 2 going out front using our property there. The exponent going out front times the 5 to make 10. Whoops, I'm off screen. There we go. Okay, so 2 going out front times 5 to make the 10 times log base 3 of 3. Well, we know log base 3 of 3. Well, again, 3 to what power gives us 3? Well, it's 1. And so this is just going to equal 10 times 1, or just 10. Okay. So let's see here. Likewise, right, I could do something like log base 4 of 32. Okay, well, again, log base 4 of 32, well, 32 is 2 to the 5th. So I can move that 5 out front there, make it 5 times log base 4 of just 2, or 2 to the 1 there if you wanted to. And 4 to what power gives us 2? Well, it's 1/2, so it's 5 times 1/2, or 5/2. All right. So there's how we can use our properties. When you have the log base a of a product, it's the same thing as log base a of the first part of that product plus log base a of the second part of the product. When you have division, it changes to subtraction. And when you have something raised to an exponent, that exponent can go out front. It needs to be, the whole quantity needs to be raised to the n here. All right, so whatever this quantity is, the whole quantity needs to be raised to the n in order for you to pull that n out front. If it's only a part of something that's raised to the n, you can't just then pull out, the n there. So for example, if you had something like, I'll do it over here. If you had like log base a of, u v to the n, well, you can't pull the n out front because the u doesn't look like the u is being raised to the nth power here. Only the v is. So what you would have to do is rewrite this as log base a of u plus log base a of v to the n. Then you cannot pull that n out front because the entire quantity v here is being raised to the n, so that n can go out front to make it like this. Like so. Okay. So you'll have some practice with using these to, well, we're going to get to some uses for this in just a second. One thing I want to mention, all right, is that there is no rule. There is no rule for log base a of u plus v or log base a of u minus v. Like this, the quantity u plus v and u minus v, okay? This does not break up. You cannot break up u plus v, a sum inside of a logarithm. And you also cannot break up subtraction inside of a logarithm. It just does not work, okay? Multiplication can become addition, division can become subtraction, but addition and subtraction do not become something else. There's no rule there, okay? So do not try and like make this multiplication or make this division or who knows what. Okay, these do not simplify when you have just a sum like that, or as a difference. Okay, so keep that in mind. All right, so let me show you some uses of these properties. Some of you probably have seen these properties used before, and there's terrible memories coming back, and you're maybe starting to sweat a little bit, and Mr. Whitmire's not here to show it to you. So, but again, I'll be able to go over this stuff with you tomorrow too, if you have any difficulties. So here are some uses. Okay, we've already kind of seen this first use, evaluating. All right, so you know we did that already. We were evaluating somewhat already, but I'll do some more here. So for example, if I have log base 5 of 25 to the 1.4 power, for example. Okay, not necessarily the most intuitive thing for us to do. There's kind of two different ways you could go about doing this if you wanted to. Option 1 is we can use our property here because we have an exponent that 1.4 can come out front. All right, and then we know that log base 5 of 25 is 2, so it'll just be 1.4 times 2, which is then just 2.8. So the final answer is 2.8. An alternative here, using one of the properties from yesterday, if I had written log base 5 and I rewrote 25 as 5 squared to the 1.4, well now I have a power raised to a power inside my logarithm there. So 5 squared to the 1.4, remember you multiply exponents when you have a power to a power, so it's 5 to the 2.8. And a property we had yesterday, that log base a of a to a power, it just ends up being that power. It just ends up equaling 2.8 there. Okay, right? Log base 5 of 5 to the 2.8. In other words, what power of 5 gives me 5 to the 2.8? Well, it's got to be 2.8 to make it match there. So there that is. All right. Let's see here, number 2. Let's try another one. The natural log of 4e to the 5th. All right, so looking at this one, I cannot yet pull this 5 out front because only the e is being raised to the 5. The 4 is not being raised to the 5th power here, right? If it was, I'd have like parentheses around this quantity. It's just the e being raised to the 5th. So I can't pull the 5 out, but since I have a product here, 4 times e to the 5th, I can rewrite it as ln of 4, or natural log of 4, plus natural log of e to the 5th. Natural log of 4 doesn't really simplify any further, but natural log of e to the 5th, that's equal to 5 times the natural log of e. The natural log of e, remember, is log base e. Log base e of e. So e to what power gives us e? Well, e to the 1 gives us e. So it's really just natural log of 4 plus 5 times 1, or just natural log of 4 plus 5. Okay, and there's our answer. All right, so number 3, we'll do one more here. Ordinarily, I would give this one for you all to try on your own at this point, but since I'm not there to go around and check and stuff, it just seems kind of silly. So we'll just use this as another example. Okay, so log base 3 of the square root of 30. Well, square root, right, can be rewritten as an exponent. Square root is the same thing as 30 to the 1/2 power. That 1/2 can now come out front, so it's 1/2 log base 3 of 30, which we can now say, but 30 is 3 times 10, so it's 1/2 log base 3 of 3 times 10. Now, why did I pick 3 and 10? Why not 2 and 15? Why not 6 and 5? Well, specifically chose 3 here because our base is 3, and so we'll be able to simplify this eventually here because, log base 3 and 3 we'll be able to simplify. So let's break this up. Now, the 1/2 here is times this quantity, so when I break up this multiplication into an addition problem, I need to make it 1/2 times the quantity, log base 3 of 3 plus log base 3 of 10, like so. The multiplication becomes addition, where we break the log up into 2 things there. That log base 3 of 3 is just 1. Log base 3 of 10 doesn't simplify any further. There's no more powers than 3 you can pull out of it. And so it's just that for the final answer. You could distribute the 1/2 back through, make it 1/2 plus 1/2 log base 3 of 10. But, debatable about whether that's any better or not. There it is. Okay? So that's evaluating, just kind of trying to simplify those logarithmic forms. Now, another way that we use this, and you'll be using it in your homework and classwork is for expanding. Taking a single logarithm and rewriting it as a sum or difference of logs. Okay? And that's typically the directions. Rewrite the given logarithm as a sum or difference of logs of other logarithms. I also apologize for the delay in the video and the audio. The reason for that is because the computer is slow and the processing / recording speed just can't keep up with the audio or vice versa. So it's going to be a little bit off, and I apologize for that. But hopefully it's all good for what you need to see. So anyway, expanding. So for example, let's say I've got log base 10, a single logarithm, log base 10 of 5x cubed y. Remember, if I don't want to, I don't need to write log base 10. It's kind of redundant. Just writing log by itself assumes that it's log base 10, but I'm going to put it there just for our purposes. And I want to try and expand this as much as I can. Well, I have three things being multiplied together, so I can break that up into a sum of three things. Log base 10 of 5 plus log base 10 of x cubed plus log base 10 of y. Okay. The only other thing I can further do here is break up this x cubed, or not break up the x cubed, I'm sorry, but bring that 3 out front of the log there for the x, because again, only the x being raised to the third there. And so there would be like a final answer. Okay. X is not a product of anything else. Y is not a product. 5, you could break up into 5 and 1, but that's kind of redundant. And you don't need to break up your numbers there. You do want to simplify it here, but log base 10 of 5 doesn't simplify. It just is that, okay, right? 5 is not an easy power of 10 there. So we'll just say that's our answer. All right, let's try another one. Let's do the natural log of 20 times the square root of x over y. All right. Now at first this might look a little daunting, but again, just kind of take it piece by piece. You don't have to break the whole thing up all at once, although that's fine. But here I see some multiplication and I see some division, but the division is kind of inside a square root, so we're going to have to kind of handle these things a piece at a time in this case. So we're going to start off with taking care of the multiplication, the general multiplication between 20 and the square root here. And so that will result in natural log of 20 plus the natural log of the square root of x over y. Okay. Natural log of 20 doesn't really simplify any further, so we're going to just kind of bring that along for the ride for now. The square root of x over y, though, that can be simplified, but we need to do something about that square root. Again, remember, square root is really to the 1/2 power. Since both of these things are being square rooted, they're both being raised to that 1/2 power. And so you can pull that 1/2 power out front, which leaves us with just x over y here in the natural log. That results, since we have division here, now we can finally break up that division. And we'll need to use parentheses here because it's going to be breaking up the single term into two terms. So natural log of x minus natural log of y. Like so. And that's the simplified form. The division becomes the subtraction there. Okay. These don't break up any further. 20, you could rewrite it as a product of like 4 and 5 or 2 and 10, but it's not really helpful because none of those will simplify since our base is e here. So it's fine to just stop right there. We've now rewritten everything we can as a product as a sum or a difference. All right. Do one more here, and then we'll get into condensing. All right, so let's say now I'm going to take the natural log of the square root of 3x plus 5 all over 7. And again, you want to kind of take maybe this piece by piece. Try not to think about doing it all at once. Just take it piece by piece. So for example, here, I see division, right? We have a quantity being divided by another quantity, so we can break that up and make it the natural log. And I'm going to go ahead and change the square root to a 1/2 power. So 3x plus 5 to the 1/2 power there. Minus, right, because division becomes subtraction, minus the natural log of 7. Now again, natural log of 7 does not simplify any further, but this 1/2 can go out front, and we have 1/2 the natural log of 3 x plus 5 minus the natural log of 7. Okay. Now at this point we have addition, so we can break it up, right? We can break up the addition in here, right? No, 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 no. There is no rule for log base a of u plus v, log base a of u minus v. All right, we have addition in here. We don't have a rule for breaking up addition. Yeah, there's a product in here, but we can't get to that product until we take care of this addition first, right? It's not 3 times the quantity x plus 5, it's 3x plus 5. To get to that 3x, you've got to take care of the addition. We can't take care of the addition. We're done. That's all there is to do here. No more. Okay. If it was 1/2 the ln of 3 times x plus 5 like that, then yes, then we can break that up and do it. It would be 1/2 ln 3 plus 1/2 ln x plus 5. But again, we can't do that because of the way it's actually written. Okay. So there's that. Moving on. Okay. Got 2 more things to look at here. Another application of those properties, instead of expanding, is to condense. Okay, to a single logarithm. So for example, 2 log base 4 of x plus log base 4 of 5. And we want to condense that to a single logarithm. Right now it's 2, right? Well, I can't quite take care of this addition because I have this 2 in front right now. So I'm going to go ahead and bring that 2 up into the logarithm, making it log base 4 of x squared plus log base 4 of 5. Now I have addition between 2 logarithms with the same base, and so addition on the outside, right, is equivalent to multiplication on the inside. So 5x squared, 5 times the x squared, or x squared times 5, but you know, we always put the coefficient in front there. And so now we've rewritten this. This is equivalent to this, but it's just now it's written as a single logarithm. Okay. So again, the 2, we kind of just use the properties in reverse. 2 comes back up as the exponent. We undo the addition, put them back together as a product, 5x squared. All right, let's try another one. 1/2 natural log of 5 minus 3 times the natural log of x plus 3 plus the natural log of x. So again, we have some exponents, some coefficients we're going to bring up and make exponents. So this is going to become, 1/2 natural log of 5 becomes natural log of 5 to the 1/2 power. The minus 3, well, we can bring the 3 up and make it minus the natural log of x plus 3 to the 3rd. And then the natural log of x is going to stay the natural log of x. It didn't have a coefficient. Okay. Now, let's take care of these pieces because we have kind of 3 things. We have a subtraction and an addition. So let's just take care of from left to right here, kind of following order of operations from left to right. Since we have subtraction, that'll become division. So natural log of 5 to the 1/2 over x plus 3 to the 3rd. And then we still have the natural log of x over here. Okay. Now we have still 2 natural logs here, and there's additions. That means this gets multiplied with this. The 5 to the 1/2 over the quantity x plus 3 cubed gets multiplied with x. So that x will go up in the numerator because it's multiplication here. And so it's 5 to the 1/2 times x over x plus 3 to the 3rd. And voila, it's 1 logarithm. So again, to review that, we had the 1/2 natural log of 5 and the 3 in front of the natural log of x plus 3. So we made those both the exponents, brought them back up into the exponents. Then we went from left to right and kind of taken a piece at a time, 2 pieces at a time. So these first 2 pieces, the natural log of 5 to the 1/2 minus the natural log of x plus 3 to the 3rd, the subtraction became division, and then with the addition we made it multiplication, so the x comes up into the numerator there. Okay. We'll do one more here. 1/2 times the quantity of the natural log of x plus 1 minus 2 times the natural log of x minus 1 minus 3/2 natural log of 4. Okay, so a couple options we have here. Option 1, we can distribute this 1/2 to the 2 terms here. Make it 1/2 natural log of x plus 1. 1/2 times 2 is going to be just 1, so it'll be minus natural log of x minus 1. And then minus that 3/2, I'm going to go ahead and bring up into the exponent here of the 4. So make it natural log of 4 to the 3/2 power. Now I still have a coefficient here I want to bring up, so I might as well go ahead and do that. The 1/2 in front of the natural log of x plus 1. Alright, and then finally, now I can start putting these pieces together. So, these 2 pieces are separated by subtraction, so we'll make that division there. So, x plus 1, whoops, natural log of x plus 1 to the 1/2 over x minus 1, and then minus the natural log of 4 to the 3/2. And then since we have another subtraction here, okay, that's going to be divided, right? So dividing the thing, that means this thing's going to go in the denominator. And so we're going to end up with the natural log of x plus 1 to the 1/2 in the numerator over 4 to the 3/2 times x minus 1, like so. Okay, the 4, again, because of that subtraction in front of the natural log of 4 to the 3/2, it goes down into the denominator. It divides the quantity here, and so it goes into the denominator. And there's our final answer. Alternatively, you could evaluate 4 to the 3/2. So 4 to the 3/2, we could do the square root part first. That would be 2 to the 3rd would be 8. So you could just say that's a value of 8 there too if you wanted to. But leaving it as 4 to the 3/2 is also acceptable. All right, last thing we're going to talk about. And this one's easy. Okay. Remember that we were kind of stuck before about how to use our calculator to evaluate a logarithm. All right. The problem with that is, for example, if I have log base 5 of 25, that's no problem, because I know, okay, 5 to what power gives me 25? Well, it's going to be 2, right? 5 squared is 25. But if I then say log base 5 of 26, well, there's no easy way for me to figure out what power of 5 gives me 26, right? And there's no log base 5 button in my calculator that I can evaluate the 26, right? If it was just log base 10 of 26, I could type that into my calculator and get an answer, right? In fact, let's see here if I can do that. Log of 26, okay, well, there it is. 1.414973348, et cetera, et cetera, et cetera. It goes on forever, never repeating, regularly at least. And so we have log base 10 of 26, right? But we can't do log base 5 of 26. How do we even do that, right? We can say this one is about 1.415. Or 414, I guess, really, but anyway. Well, the trick is that we need to be able to change this base 5. Can we rewrite this log base 5 of 26 as log base 10 so we can then use our calculator? And the answer is we can. So the formula, okay, for the changing bases is this. If you have a logarithm, for example, log base a of x, and you want to change its base, you want to rewrite this logarithm in terms of another base, it's very simple. All you have to do is pick your base, and do log base, your chosen base of the x, divided by log base, your chosen base, right, b, of the old base, a. So in other words, if I wanted to take log base 5 of 26, I can choose whichever base I want. So I could say, I'll use log base 10, because that's in my calculator. I'll say log base 10 of 26 divided by log base 10 of 5. And so we go to our calculator, log of 26 divided by log of 5. 2.024, we'll say, approximately. Which makes sense, right? Because 5 to the 2 is 25, so 5 to the 2.024, right? We have to be a little bit higher than 2 to get that 26. So 2.024 makes sense. All right? Of course, this works for problems that we know the answers to as well, right? So for example, let's say I have log base 2 of 32. Well, log base 2 of 32, we know it's going to be 5, right? It's got to be 5 because that's what the power of 2 is. It gives us 32. But let's just try it with the log formula here, or the change of base formula. Log base 10 of 32 over log base 10 of 2. Log of 32 divided by log of 2. And there it is. You get 5. Just like we should. Okay, so it even works for the nice numbers. And of course, you don't have to use the log, log base 10. You can also use natural log. So for example, natural log of 30 over natural log of 4. Okay, natural log is just below the log button, next to number 4. So natural log of 30 divided by natural log of 4, 2.453. And there it is. Okay. So that's all I have for you guys. All right. It's not easy stuff, I understand. I'm still going to give you an assignment here, and I want you to give it a shot. Try your best. Read through as much as you can. Try and get as much of them done as you can. Remember, these are odd problems. They'll be in the back of the book. Well, most of them are odd problems. They'll be in the back of the book, so you can check that out. And of course, I'll be back again tomorrow to answer any questions and to help you out with any difficulties or confusion you might have. So I'm going to write the assignment here. It's going to be page 241, numbers 15 to 21, 30 to 63, and 69 to 81. And for all of those, you only need to do every third problem. Okay, so for example, you'll do 15 here, but not 18. 15, but then not 16 or 17, but 18, right? The third problem after that. So 15, then 18, and then 21. And then you'll do 30, 33, 36, 39, 42, so on and so forth. And then 69, 72, 75, so on and so forth, up to 81. Okay, every third problem, which means you'll get some odds, but also some evens there. I also want you to do, actually, no, that's it. Never mind. All right, so there's your assignment. Okay, you can pause the video there if you need to write it, but I'll leave that up. And then, hope you guys have a good rest of your day, and I'll see you all tomorrow.